everybody! In this video we're going to introduce dictionaries, and this is the last major data type that we'll cover in this unit. So let's just jump in and let me show you an example of what a dictionary looks like and go from there. So let's say D equals, and I'm going to use curly braces. So this starts exactly the same as set, but you'll soon see what the difference is. So let's say I want to kind of imagine I am in a traditional grading class, so not the specs grading that we're using, and I want to say, well, what's the cutoff for an A? What's the cutoff for a B? So I can say, okay, cutoff for A, so I'm going to type A, then colon, and let's say 90 is the cutoff for an A. So already here you can see something that's different than set is we have this colon, and what this is saying is A corresponds to 90. Then I can do comma, whoops. Then B, let's say this corresponds to 80, C to 70, D to 60, and let's just say F to 0. So I can evaluate this, and I can check, well, what's the type? And we can see here, it's a dictionary. So again, how is this different from set? Well, we have these colons here separating the left and the right hand side. This left hand side, so this thing here, this A, B, C, D, and F, these are called keys. So you can think of it as like a key for looking up. We'll say, I want to know what's the cutoff for an A. So that's the key. You say, I want to find A, and it returns what's called a value, which is the number here on the right. So 90 is a value, 80 is a value, 70, 60, and 0, these are values, whereas A, B, C, D, and F, these are called keys. So in this case, all of our keys are strings and all of our values are integers, but I'm going to show you a couple of examples now where this doesn't have to be the case. So let's start by seeing something that doesn't work. I can say D of 0. And you might expect after the previous couple of videos, oh, maybe this would return like the first like key value pair. But what actually is happening here is Python is saying, give me the value corresponding to the key 0. But if you notice here, there's no key 0. So that's why we get what's called a key error. It's basically saying there's no key called 0. On the other hand, I could do something like D of B. So what this is saying is, give me the value corresponding to B. And we can see here, well, that's 80. Let's say I did want to have a key called 0. So what I can do is I can say D of 0 equals, and now let's say instead of having just an integer as a value, I could have a list if I wanted. So I could have 3, 1, 4, 1. And now if I look at the dictionary D, I can see I have a key of 0 that corresponds to a list 3141. So values can be almost anything that you want. We'll see in a little bit that keys are a little bit more tricky. You can't just have anything for a key, but values, there's a lot of flexibility. Let's say though, so I'm looking at this and maybe I said, oh, the cutoff for a B is wrong. I need that to be 85 instead. So I could say D of B. So this is saying, look at the key B, update the value to 85. So now if I look at the dictionary, B has been updated to 85. So this highlights an important fact about dictionaries is you can only have one value for each key. So you might have thought, okay, maybe another key gets added that's 85. But what happens is the original key B, that just updates the value to 85. So maybe another example. So this is going to be a little bit confusing. But so remember here, 0 was a key. Now I'm going to have the string 0. So here was the integer 0. Now let's have the string 0. And just to show you the flexibility of how we really can put almost anything we want for a value, let's say that this itself is a dictionary. So I could have the word hello correspond to the value first word. And then I could have world corresponds to the value second word. So what this is doing is it's saying add a key 0 that has a value that's this dictionary. So let's take a look. So I can see here, 0, the integer, has a value that's this list, whereas 0 as a string has a value that's a dictionary. So hopefully I've convinced you that the values are pretty flexible. I mean, I've had a list, I've had a dictionary, but now let's see an example of how keys are a little bit more rigid. I have to be a little bit more careful. So maybe first thing, let's kind of have a reminder. Let's say I wanted to create a set. So say my set is equal to 3, 1, and then let's say list 4, 1. And does anybody remember what this error is going to be? So it's this hashable error with the type list. So list cannot go in a set. On the other hand, I can say, well, okay, what if instead my set is equal to 3, 1, and then 4, comma 1? So that works just fine. So tuple can go in my set, but list cannot. And we're going to see very similar behavior for keys in dictionaries. And again, it comes down to the issue of the fact that lists are not hashable. So for instance, let's say I wanted to add a dictionary key. And let's say I want to add the key 4, comma 1, and I want to say this corresponds to the value Yasmin. Well, we get an issue here saying, oops, and I think I made a mistake here. I should have used square brackets. Here we get the hashable error. So list is not hashable. It cannot be used as a key in the dictionary. On the other hand, let's say I want to add the tuple 4, 1 as a key, and as Yasmin. We can see here, well, that does work. And if I take a look at the dictionary, I can see that the tuple 4, 1 can be a key. So just very important reminder about how lists are unhashable. So they can't go into sets and they can't be keys in dictionaries. But tuples, on the other hand, can go into sets and they can be keys in dictionaries. So that's all I wanted to show you about dictionaries in this video. I just wanted to emphasize that these are one of the most important data types in Python. If you're reading documentation or looking at other people's code, they show up all the time and they can be very useful. So in the grade tracker that I wrote for this class, dictionaries are used a lot. So if you want to take a look at the code for that, that might be fun. Otherwise, thank you for watching and I'll see you in the next video.